ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
So in yesterday's class we discussed about average velocity, average speed and its applications in different conditions. Now we can discuss about acceleration. Acceleration. How can we define acceleration? How can we define acceleration? Acceleration means rate of change of velocity. Acceleration in the sense rate of change of velocity. So that means simply acceleration can be written as general formula v bar minus u bar divided by t. Generally acceleration is defined as rate of change of velocity. That's why acceleration can be written as v bar minus u bar divided by t. Why we are writing v bar and u bar? V bar and u bar in the sense velocity is a vector quantity. Velocity is a vector quantity. Any vector quantity represented like this. We already discussed about that. The first class, scalar quantity and vector quantity. So general representation. So acceleration can be written as v bar minus u bar divided by t. This is not algebraic subtraction. Just it is not the algebraic subtraction. Based on the direction of the body, direction of motion of the body, based on the direction of motion of the body, we can decide the value of acceleration. That means, for example, if a body moving in this direction, so let us say velocity is u. After certain time, the motion of the body is like this. After certain time, the motion of the body is like this, and this velocity is v. Initial, this is the initial situation, and this is the final situation. Initial and final conditions are exactly opposite in direction. Initial and final conditions are exactly opposite in direction. Opposite in direction. That's why velocity is a, what we discussed already, velocity is a vector quantity. Vector quantity means if one direction is positive, in another direction it must be negative. Just like, see here. So let us say it is positive x-axis and negative x-axis. Positive x-axis and negative x-axis, let us say it is origin. Origin. In the positive x-axis, we can consider the values are positive, but in the negative x-axis, the values are negative. In the same way, if one direction the vector is positive, in opposite direction that must be a negative value. So that means if this direction is considered as positive, this direction is negative. If this direction is considered as positive, this is negative. Or if we consider this is positive and this is negative. So depends on the direction, the acceleration value changes, and this is the exact definition of acceleration. Change in velocity divided by time. Acceleration is final minus initial divided by time. This is acceleration. So now let us one condition here. If initial and final conditions are in the same direction, if the initial and final conditions are in the same direction. So same direction, that means let us say it is u and it is v. This is initial and it is final, both are in the same direction. Then acceleration can be written as, so simply v minus u by t, change in velocity. While writing the change, always we must write final minus initial. While writing the change, always we must write final minus initial. That's why v minus u. That means in this direction we are considering this is negative. That's why we are writing minus u. So for example, next condition, if the initial and final conditions are opposite, initial and final conditions are opposite, that means let us say it is u and it is v. This is initial and it is final position. Initial and final positions are opposite in direction. Opposite in direction. If one is positive, another one is negative. If both are in the same direction, the condition is change in velocity by time or rate of change of velocity. So final minus initial. So both are in the same direction. Both are in the positive x-axis. But here this v is considered as positive and u is negative here. U is negative. That means here the initial conditions are opposite in direction and here it is v minus u. So generally acceleration formula is change in v bar minus u bar divided by t. V bar minus u bar divided by t. So these are the positive x-axis. That means it is positive and it is also positive. But according to the formula, we are writing v minus u by t. V minus u by t. Change means always we must write final minus initial. Always we must write final minus initial. This is final, minus into positive, that gives minus. Minus into positive gives minus. That's why v minus u by t. Next, initial and final conditions are opposite. Here this is positive, that means it is negative and it is positive. Opposite, this is considered as negative x direction, that's why it is negative and it is positive because it is positive x direction. Here also acceleration can be written as change in velocity by time, change in velocity. That means general formula v minus u, but v is minus v, u is minus u divided by t. A is equals to minus of v plus u by t. Minus of v plus u by t. So this is acceleration. So that means the direction of acceleration changes because it is also a vector quantity. Just you have to remember this, in the same direction the velocity must be changed, v minus u by t, but in opposite direction this is v plus u by t. Generally this concept is based on vectors concept. So after completion of vector chapter, you know about this clearly. So up to that remember this. So initial and final conditions are same direction. So this is positive x direction, that's why this is positive, this is positive. But according to the definition of acceleration, rate of change of velocity, change can be written as always we must write final minus initial. That's why v minus u by t. If the initial and final conditions are opposite, then this is positive, it is opposite direction, that's why it is negative. Again according to the definition, acceleration, change in velocity by time, v minus u by t, but here v is negative, that's why minus v minus u by t, minus of v plus u by t. This is acceleration, rate of change of velocity, and acceleration is a Next, so here so next here the condition is acceleration is vector quantity. Acceleration is a vector quantity. So what is the direction of acceleration? Vector means it must have both magnitude and direction. What is direction? So the direction of acceleration is in the direction of change in velocity. The direction of acceleration is in the direction of change in velocity. How the velocity changes, in that direction the acceleration exists. That is the direction of acceleration. Now the unit of acceleration. So acceleration is equals to, generally we can write change in velocity by time or the velocity by time. Velocity unit meter per second. Velocity unit is meter per second divided by time is second. Therefore A is equals to meter per second square. This is the unit of acceleration. Acceleration formula is generally change in velocity by time, or numerically we can write it as velocity by time. Velocity unit is meter per second, meter by second time unit is also second, that is why meter per second square. This is the unit of acceleration. Now so what is the types of acceleration? So uniform acceleration and non-uniform acceleration and instantaneous acceleration. First we can discuss about uniform acceleration. So how can we define about uniform acceleration? Uniform acceleration means uniform acceleration. So that is acceleration in the sense rate of change of velocity. Uniform acceleration means equal changes in velocities in equal intervals of time. Equal changes in velocities, equal changes in velocities in equal intervals of time. Equal changes in velocities in equal intervals of time, that is called uniform acceleration. So how it can be equal changes in velocities? See here, so let us say the body moves like this. In the first second, its velocity is 1 meter per second. Next it is 2 meter per second, 3 meter per second, 4 meter per second, 5 meters per second, 6 meter per second, like that. Time intervals. So in the first second its velocity is 1 meter per second. In the next second its velocity is 2. What is the change here? 2 minus 1. How much? 1 meter per second. Here its velocity is 3 meter per second. Next it is 3 meters per second. That means what is the change? 1 meter per second. Next here it is 3 meter per second. Next it is 4 meter per second. Next what is the change? 1. So 4 and 5, the change is 1. 5 and 6, the change is 1. So equal changes in velocities in equal intervals of time. Here let us say it is 0 meter per second. In 1 second the velocity changes to 1. In the next second the velocity changes to 1. Here it is 1 meter per second, 2 meters per second. How much changes? 1. Next here it is 2, here it is 3. How much changes? 1. Here it is 3, here it is 4. How much changes? 1. In each is uniform acceleration. So equal changes at velocities in equal intervals of time. So let us say first second. So velocity changes from 0 to 1. In the next second changes from 1 to 2. Next second 2 to 3. Next second 3 to 4. So in each and every interval, what is the difference here? 1. Here the difference is 1. Here also the difference is 1. So equal changes in velocities in equal intervals of time, that is called uniform acceleration. Next, non-uniform acceleration. Non-uniform acceleration. Unequal changes in velocities in equal intervals of time. Simply we can unequal changes in velocities in equal intervals of time. Unequal changes in velocities in equal intervals of time. So that is, see here. So let us say divides this. So here let us say 1 meter per second, 1 second. Let us say 5 meter per second in 2 seconds. Let us say 6 meters per second in 1 second. 8 meters per second in 5 seconds. 2 meters per second in 4 seconds, like this. Here the change is 4. Here 1 to 5, the change is 4. Here 5 to 6, the change is 1. Here 6 to 8, the change is 2. 8 to 2, the change is minus 6. So like that. So unequal changes in velocities in unequal intervals or equal intervals, whatever it is. So that is called non-uniform acceleration. Next, one more condition is instantaneous acceleration. Instantaneous acceleration. So instantaneous acceleration means the acceleration of the particle in very small interval of time. Acceleration of the particle in very small interval of time. So acceleration of particle or body, whatever it is, in a very small interval of time. Acceleration of the body or particle in small interval. That means here acceleration instantaneous limits delta t tends to 0, delta v by delta t. Limit delta t tends to 0, delta v by delta t. So here delta v by delta t is the average velocity. Delta v by delta t is the average velocity. In a very small interval of time, that means time interval nearly equal to 0, that means less than 1 second approximately. In that situations, what is the acceleration? This can be written as dv by dt. dv by dt. This is the instantaneous acceleration. Limit delta t tends to 0, delta v by delta t. So, average velocity in a small interval of time. So, that is dv by dt, dv by dt. So, differentiation of velocity with respect to time, that is called instantaneous acceleration. So, this is about acceleration. So, uniform acceleration, non-uniform acceleration, instantaneous acceleration. And see here. And some important points about acceleration. So, first one, if any body moving with increasing velocity. So, okay, we can discuss about some important points regarding acceleration. So, for example, if a body moving with increasing velocity, so velocity increases, let us say 10 kilometers per hour, 20 kilometers per hour, 30 kilometers per hour, like that. So that means if you are in the, for example, we are driving the car, for example, first gear, the speed limit may be 20, second gear 30, 40, 50. That means if we are changing the gears, the speed gradually increases. If you mention the direction, that's velocity also increases gradually. That means if a body moving with increasing velocity, then we can say that that body is accelerated. So that means acceleration. If a body moving with increasing velocity, then we can say that that body is moving with acceleration, or that body is accelerated. Body is moving with acceleration. Body is moving with acceleration. If a body moving with increasing velocity, then we can say that that body moves with acceleration. So in the same way, if the body moving with decreasing velocity, if the body moving with a decreasing velocity, that means velocity of the body decreases gradually. For example, if we apply the brakes, what happens? Velocity gradually decreases and finally comes to rest. In this situation, if the body moving with a decreasing velocity, then we can say that that body moves with retardation or deceleration. If the body moving with a decreasing velocity, then we can say that that body moves with retardation or deceleration. That means negative acceleration. If the body moving with increasing velocity, that is accelerated motion. If the body moving with a decreasing velocity, that is retarding motion or decelerating motion. So remember that these 2 points, increasing velocity, decreasing velocity. These 2 are very important. And one more point is, if the body moving with uniform velocity, then the acceleration of the body must be 0. then the acceleration A is equals to 0. Any body moving with uniform velocity. Uniform velocity means velocity of the body does not changes with respect to time. How can you define acceleration? Rate of change of velocity is the acceleration. But here the velocity does not changes with respect to time. That's why if the body moving with uniform velocity, the acceleration of the body must be equal to 0. These are the 3 points. Body moving with increasing velocity, then we can say that the body moving with acceleration, or this is also called as accelerated motion. Next, here the body moving with decreasing velocity, now we can say that body moving with retardation or deceleration, then we can say that this is retarding motion or decelerating motion or deceleration. Next, body moving with uniform velocity, the acceleration of the body must be equal to 0. Next, so let us derive kinematical equations. So I am deriving these equations in general method. I am not going through integrating method. See here. So first equation, kinematical equations. Kinematical equations of motion. So 4 equations. These are the basic equations. These equations can be used throughout physics in the first year and second year. So first equation, V equals to U plus AT. How can we derive that equation? See here, we know acceleration is equals to rate of change of velocity. Rate of change. Acceleration can be written as rate of change of velocity. So generally acceleration is equals to V minus U by T. General formula. That means cross multiplication, AT can be written as V minus U. So from this V is equals to U plus AT. This is the first equation. Acceleration is equals to V minus U. AT is equals to V minus U. V equals to U plus AT. V equals to U plus AT. So what is V here and what is U here? A in the sense acceleration. A in the sense acceleration. So V minus U. V is equals to U plus AT. V is equals to U plus AT. Then so second equation here, V in the sense velocity at the end of time. Velocity at the end of the time. So that means T is the time interval. So we start the time and we end the time in a particular instant of time. Let us say the velocity of the body after 5 seconds. That means after 5 seconds this is the V. V is the velocity at the end of the time. After how many seconds we are ending, how many seconds we are calculating, or how many minutes we are calculating, and the last time, that is V is the velocity at the end of the time it is. And U can be written as velocity at the start of the time. So V is the velocity at the end of the time and U is the velocity at the start of the time. So generally we can call it as V is considered as final velocity and u is considered as initial velocity. V is considered as final velocity and u is considered as initial velocity, but actual representation of v is velocity at the end of the time and u is the velocity at the start of the time. And what is a here? A is acceleration. A is the acceleration and t is the time interval. What is the time we are calculating? What is the time we are considering? That is the condition. So this is the first equation of motion. V is equals to u plus at. When we can use this equation while doing the problems, velocity as a function of time. Velocity as a function of time. V equals to u plus at. That means velocity varies with the time. Velocity varies with the time. That means this is final velocity, this is initial velocity, this is acceleration, and it is time. So in this situation we can use this equation. So remember that this is the velocity as a function of time. Knowing the formula is not important. When we have to apply this formula, that is very, very important. So that is the conceptual thing. When we can use this formula, that is very important. So V equals to U plus AT. Second equation. So for example, so general equation, we know second equation of motion, displacement is equals to general formula, we are considering average velocity into time. So so displacement is equals to general formula velocity into time. Here I am considering displacement is equals to average velocity into time. So displacement is considered as S. Average velocity u plus v by 2 into t. Initial velocity is u and final velocity is v. Then average velocity, average of those two, that is u plus v by 2 into t. So but we know v is equals to u plus at. So S is equals to u plus, in place of v we can substitute u plus at divided by 2 into t. Then S is equals to u plus u, 2u plus at by 2 into t. Then S is equals to 2u by 2 plus at by 2 into t. 2 gets cancelled. S is equals to ut plus half a t square. This is the second equation of motion. So generally we know displacement is equals to average velocity into time. Displacement is equals to average velocity into time. That's why S is equals to u plus v by 2, average velocity. Average means initial plus final by 2. Average, we have two velocities. Initial velocity is u and final velocity is v. What is the average of those two? Initial plus final by 2, that is the average. But we know first equation of motion, v equals to u plus at. Then that is v equals to u plus at, u plus at, that is 2u plus at. So based on this, S equals to ut plus half at square. When we can use this equation? S is means displacement. Displacement is the function of the time. S equals to ut plus half a t square. That means displacement is the function of time. Then in that situation we can use this equation, displacement as the function of time. Previous value is, this is velocity as a function of time and this is the displacement varies with time. Next, third equation. So third equation, From equation we know V is equals to U plus AT. Squaring on both sides. V square is equals to U plus AT whole square. So from this V square is equals to, let us say A plus B whole square formula. U square plus A square T square plus 2UAT. A square plus B square plus 2AB. So from this V square is equals to U square plus T here. A plus B whole A square plus B square plus 2AB. Next ikkada 2UT common. So here it is 2A common, UT plus half AT square we get. Here 2A common, remaining term is UT. Here we don't have 2, that's why it is half. 1A comes out, that's why A and T square. V square is equals to U square plus, if 2A common here, that is UT plus half AT square. Then V square is equals to U square plus 2A, UT plus half AT square is yes. Second equation, S equals to UT plus half AT square. Therefore, from this we can write V square minus U square equals to 2AS. V square minus U square equals to 2AS. Velocity as a function of displacement. Velocity as a function of displacement. V square minus U square equals to 2AS. So these are the equations. V square minus U square equals to 2AS. So first one is, so this is the V equals U plus AT. We are squaring on both sides. So V square A plus B whole square formula. A square plus B square plus 2AB. A square plus here 2A common. UT plus half AT square. UT plus half AT square is nothing but yes. So from this we calculated this. So next formula is, so this, then we can write formulas here. So first equation is V is equals to U plus AT. Second equation is S is equals to UT plus half AT square. So third equation is V square minus U square equals to 2AS. And fourth equation is Sn is equals to U plus A into N minus half. So the difference between these two is, this is the S equals to UT plus half AT square. This is also distance varies with the time, and here also Sn is equals to U plus A into N minus half. This also distance varies with the time. But what is the difference between these two equations? This is the distance after certain time interval. That means distance traveled by the body after 2 seconds, after 3 seconds, after 4 seconds, after 5 seconds, like that. In the total complete 5 seconds we have to consider. But in this situation, Sn is equals to U plus A into N minus half. Here the displacement of the body in that particular time interval. That means displacement of the body in second. Here it is, let us say displacement of the body after 2 seconds, then we can use this equation. That means we have to consider 2 seconds. First second to the total 2 seconds we have to consider. But here Sn is equals to U plus A into N minus half. Second displacement of the body in the second. Second means only second we have to consider. This is 1 and 2. After 2, this is second. So that is the difference between these two in that particular. So for example, the displacement of the body after 5 seconds. After 5 seconds we can use this. That means 1, 2, 3, 4, 5, total 5. After 5 seconds we have to consider. But displacement of the body in the 5th second means we have to consider this one. In that particular second, 5th one means only one. that is this one. So these are the 4 equations. When we can use this equation, v equals u plus at, velocity as the function of time. And when we can use this equation, s equals ut plus half at square, displacement as the function of time. When we can use this v square minus u square equals to 2as, velocity as a function of displacement. Velocity varies with the displacement. Here the distance or displacement varies with the time. Velocity varies with the time. And here also displacement as a function of time here. Displacement as a function of time. These are the 4 equations. Here some terms we must remember. So first condition is, if any body starts from rest, that means at the start of motion the velocity of the body is 0. If any body starts from rest, that means at the start of motion the velocity of the body must be 0. At the start of motion, velocity of the body must be equal to 0. If any body starts from rest, that means initial velocity is 0. It's very important. If any body starts from rest, initial velocity of the body must be equal to 0. Second point, if the body finally comes to rest, that means if the body finally comes to rest, initially body moving with certain speed, and finally the body comes to rest. Finally comes to rest means final velocity must be equal to 0. Final velocity must be equal to 0. Any body starts from rest, initial velocity is 0. If the body finally comes to rest, final velocity must be equal to 0. And third point, already we discussed this. If the body moving with uniform velocity, acceleration of the body is equals to 0. If a body moving with uniform velocity, the acceleration of the body must be equal to 0. These are the points we have to remember in this situation. V equals to u plus at, s equals to ut plus half at square, v square minus u square equals to 2as, sn is equals to u plus a into n minus half. So in this situation, first condition is, if any body starts from rest, initial velocity must be equal to 0. If the body finally comes to rest, final velocity must be 0. So that means if any body starts from rest and the body is in motion, any body starts from rest and the body is in motion, that means this is called accelerated motion. Initially velocity is 0, but if the body moving means velocity gradually increases. If the velocity of the body increases, this motion is called accelerated motion. And if the body finally comes to rest, that means velocity of the body gradually decreases. That means here this is the situation is applying the brakes. If we apply the brakes, the velocity of the vehicle decreases and finally comes to rest. That is the situation, and that motion is called decelerated motion. Next, body moving with uniform velocity. That means velocity of the body does not changes with respect to time. That means acceleration of the body must be equal to 0. This is called uniform motion. Accelerated motion, retarding motion or decelerating motion, uniform motion. These are the 4 equations you must remember about this. So these are the 4 equations. Let us do one problem. Example problem. If the velocity of the body changing from 4 meters per second to 8 meters per second in 4 seconds. If the velocity of the body changing from 4 meters per second to 8 meters per second in 4 seconds. Find the distance traveled in this time. The question is, find the distance traveled in this time. So velocity of the body changing from 4 meters per second to 8 meters per second. What is the initial velocity here? Here the way of understanding the problem is very important. If you understand the problem quickly, then the equation, only those 4 equations, v equals to u plus at, s equals to ut plus half at square, v square minus u square equals to 2as, sn is equals to u plus a into n minus half. These are the equations, no other equations involved here. Only those 4 equations. Throughout this chapter, we can use only these 4 equations. But how to use these equations are very important. That is the based on way of understanding the problem. See here, the velocity of the body is 4 meters per second. That means initial velocity is 4 meters per second and final velocity is equals to 8 meters per second, and the time is given as 4 seconds. Now what we have to find out? Distance or displacement. So based on these 3 parameters, we don't have the equation to find out the distance, or it is not possible to find out the distance by using u, v and t. For that, first calculate from equation v is equals to u plus at. V is 8, u is 4, t is 4. So from this, 8 minus 4 is equals to a into 4. 4 is equals to a into 4. Therefore, a is equals to 4 by 4, 1. So acceleration of the body is equals to 1 meter per second square. We calculated the acceleration first. Acceleration of the body is equals to 1 meter per second square. Next, we can use from equation v square minus u square equals to 2as. 8 square minus 4 square is equals to 2a is 1. Yes, we have to find out. 64 minus 16 is equals to 2s. So 64 minus 16, 48. S is equals to 48 by 2. So S is equals to 24 meters. So this is 24 meters. This is one way. Or we can use S is equals to ut plus half at square. U is 4, T is 4, half A is 1, again T is 4. 16 plus 16 by 2, 8, 24 meters. So anyway, we can calculate this problem. So first we have to calculate the acceleration, and we can substitute the acceleration in any one of these 2 equations. So then we can get both ways are correct.